So we're looking at an observer in a lighthouse 350 feet above sea level and observes two ships directly offshore. The angles of depression to the ships are 4 degrees and 7 degrees. How far apart are the ships? And we're going to leave the answer in exact form. We're not using any calculators in this example. Now, before we start to draw a picture, I want us to remember what angle of depression versus angle of elevation mean. So this is an angle of depression. So when we're looking at these examples, we have to remember that if we're looking at, for example, angle of elevation, that is the observers at the bottom, this is the horizontal, and the angle of elevation is this angle from the horizontal going up, right? So here is that angle. Now the same thing, if we're looking at an angle of depression, so the observer is here, and you have to go towards that horizontal. So this is the angle of depression. So I think in a lot of these problems that I think a lot of students do the angle right here, thinking this is the correct angle, but it's not. So remember, just like we do in reference angles, the angle has to be towards the horizontal line or our x-axis normally. Okay, so remember that when we're drawing this, so angle of depression is this angle here. Now, before we go even further on that, we could write or draw a different triangle with that if we know some of our geometry. So if we know that this is an angle of elevation here, so this is the horizontal, say we have another horizontal here, let's say these are parallel lines. Remember that alternate interior angles are congruent. So if you draw a triangle, and I'll draw the example in the lighthouse example, we could redraw the triangle, so then that way you're working with a triangle that has this side on the bottom as opposed to the top. Okay, so it just depends up to you on what you see. But again, the biggest thing is notice the angle of depression is from this horizontal, not here on the y-axis. So an observer in the lighthouse 350 feet above sea level. So let's just say this is the lighthouse here. So this is 350 feet. And observes two ships directly offshore. So the first one, the angle of depression is 4 degrees. So remember, it's toward this horizontal. So 4 degrees, not looking, or she's not looking very far down. So 4 degrees, that is actually this angle here, 4 degrees, and then it's perpendicular, and here is the angle. Then it ships another, it observes another ship 7 degrees. So looking a little further down, 7 degrees, that angle would be, let's just say, here. And then so we finish the triangle, right angle here. And so this angle is 7 degrees, just to kind of get a picture. So if you wanted, we can go ahead and redraw this triangle. So if I drew, this is the horizontal line, this is the ocean. And so if I wanted to redo this 4 degrees and I wanted this to be the bottom, the 4 degrees is actually this angle here, 4 degrees. Then if we wanted another one with this 7 degrees, because we wanted it at the bottom, then this would be 7 degrees. So let's just kind of finish up these triangles. So this is my 7 degree right triangle, and I changed the colors, but that's okay. And then the 4 degree right triangle is in the green. Okay, so maybe this will make a little bit better picture for you. And you could do that if you needed to. And so now let's try to figure out some of these pieces. So I went ahead and erased some of these pieces here. Okay, so now we know this side here, the one with the little triangle, let's just call that A. And then this over here, the larger triangle, let's just call that X. Now our goal is we really want to find the distance between these two ships here. So when I think about that, really what I need is I'm going to take X and subtract A from it, and that'll give me this distance. So let's write some trig ratios. We have so far 4 degrees. This is 4 degrees. And so what ratio can we write? Well, we can write 4 degrees, tangent of 4 degrees equals 350 opposite over adjacent, and that is our x, because we're looking at the very big triangle right here. Okay, this triangle right here. So that's our first ratio we can write. Then let's write the other one with the 7 degrees. So let's say we can say tangent of 4 degrees or 7 degrees equals 350 now over a. So remember, we're trying to solve for x minus a. So we have an x here and we have an a here. So let's try to rewrite these equations to get them isolated. So we can multiply the x to both sides. And then so we get x tangent of 4 degrees equals 350. I know some of you can probably do this without doing that step, but this is tangent of 4 degrees. Then over here, we could do the same thing. Really, if you see it, you can just rewrite it. They just switch places. These switch places. So a equals 350 over tangent of 7 degrees. Now, I know the answer had cotangent, right? So remember, if it's in the denominator, how do you get it right to the top? Well, you say this is 350, x equals 350, cotangent of 4 degrees. Then for the a value, you do the same thing. A equals 350 times tangent of cotangent of 7 degrees. So we're really looking at x minus a to get the distance. So x is cotangent 350 times cotangent of 4 degrees minus our 350 times cotangent of 7 degrees feet. And there is our answer.